Welcome.
The Pathology Innovation Collaborative Community is a regulatory science initiative that aims to facilitate innovations in pathology, as well as advance safety and effectiveness evaluation. The PI Collaborative Community aims to harmonise approaches to speed delivery to patients through collaboration in the pre-competitive space. The PI-CC is open to all stakeholders, public or private, including but not limited to academia, industry, healthcare providers, patients, and advocacy groups. Meetings of this kind are an example of lawful activity under federal antitrust law because the focus of the meeting is on government action or policy, including the industry's responses or positions taken with respect thereto. However, antitrust monitoring is needed for companies' own protection, since they are direct competitors meeting together. These meetings need to stay within protected subject matters and need to be monitored so that they do not stray off into inappropriate areas, such as pricing and price terms, sales and service territories for particular products, customers and customer territories, each company's individual decisions regarding selection of suppliers or customers, marketing plans and especially future marketing plans or new product offerings, other proprietary or competitively sensitive information. Today's meeting will follow the written agenda, and there will be no discussion of pricing or other prohibited topics. If the discussion veers into those topics, we will terminate the discussion. If you have any questions or concerns about the propriety of a discussion, please raise it immediately, and we will take a break to determine how best to proceed. The Medical Device Innovation Consortium acts as the formal convener, and we will follow their conflict of interest policy. For additional information, we defer to our Code of Conduct and our website, www.pathologyinnovationcc.org. We look forward to moving the field forward.
Can you start?
This meeting is being recorded.
All right, welcome to the, I don't know if this is the second SEER 2.0 meeting, but the total probably fifth meeting or so. So welcome everyone and welcome back. Thank you, Uta, for calling in. I know it's a holiday in Germany.
Actually, it's not the holiday today. Yesterday was the holiday. It was suspension. But today is just the day in between. So some federal states have the day off for school. So my youngest son, but the elder kids went to school today, more or less.
Okay. Then I see someone new here. All right. Emma, why don't you take it away?
Absolutely. Ula, if I could just share my screen.
You should be able to.
Awesome, thank you. So like Joe said, thank you everyone for coming. Here's our second data review meeting for SEER 2.0. I thought we would start off with a little bit of a recap of the project overview for anyone that just is new or wanted a reminder. And then we could go over how we pulled the data files, a little bit of our analysis so far, and ending with some new trends in technologies that are upcoming. So as we kind of talked about last, I guess it was Tuesday, not even last week, the key question that we're trying to answer here is, to what degree do pathologists depend on light microscopy for cancer diagnosis? And with no clear answer in the current literature, we are really looking at using the SEER database to get that kind of idea of a percentage rendered by light microscopy, with secondary endpoints of looking at this percentage by ICD-10 code, primary tumor site, or state of patient residence, or anything else that we can come up with as a group. As just a quick recap, the diagnostic confirmation categories for SEER look as such, where 1 through 4 represent diagnosed through microscopic means, my apology, 5 through 8 are non-microscopic means, and 9 is unknown. With that, I thought we could run through the data pull steps together. A quick note is that when we began this project, we were working with the limited field data 21 registries from the November 2020 submission. which covered years 2000 through 2018 of interest. In April 2022, so just last month, the next year of data became available in the 22 registries November 2021 submission. So now we have an additional year of data and more comprehensive counts for prior years. So with that, I apologize. I'm going to share. I thought we could just walk through together how to pull the data. This is also available on the PyCC website under SOP for data pull, I believe is the title. And there's just a step-by-step guide. So we can just follow along with that here. We use a case listing session. Well, first you'll need to sign up for a SEER stat account. I guess I should start there. You have to get approved. It typically takes about an hour. It's not very, it's not too bad, but then you can download this SEER stat software. It's only available on a Microsoft machine. So here I'm using a Parallels Windows emulator on my MacBook, which is why everything looks a little funky. But then you're able to come into the SEER stat software. In a case listing session, it'll give you some warnings. And we are able to see all of the databases. We've chosen to use the Incidence SEER Research Limited. More warnings. Awesome, thanks Ula for putting that in the chat. So the 22 registries covers everywhere in the country except for Detroit. Not exactly sure why they made that change, but that is across the board for the SEER registries. And then you're able to go to table, and here we can add variables of interest for as we want them. So we're interested in the year of diagnosis as a column. We're interested in the primary site, or no, we're interested in histologic type, the ICD-10 code, of course, and also of note, just to make it easy for us, its behavior. And that will give us the ICD-10 code along with a longer title for the disease, and then the diagnostic confirmation. In addition to that, we would just like to include patient ID, which gives us just a general idea of just a row name. And with that, we then want to limit what we have. So there should only be 5 columns. It's a very standard data set. We can go and limit. This would give us 2000 to through 2019. In our data, we've really only taken a look at 2010 through 2019, which we can select here just to limit it. Press OK. And then just execute. And it takes a minute or two, which you can see here, it runs pretty fast. And you'll get thousands of cases that hopefully will pop up in a second as a matrix that you can export as a CSV. I choose to use RStudio for most of my analysis. So you can see on the SOP especially, I've walked through the steps of how to run concordance numbers for this data. Just very simply, we've split it from solid tumors and heme tumors, and then we distinguish by year. And so you can just check the count numbers per year for solid and heme against the numbers that we got. We've replicated it within the group and we all come to the same conclusion, but I welcome anyone to repeat, and I'd love to hear anything that you find. Of note is this can also be replicated, like I said, with last year's data, which means that the number counts are slightly different. Both are available on the PyCC website. And you should just be able to choose the right database and the numbers should pop up. I was hoping this was going to run quickly enough, but
it's the demo effect. Don't worry, it'll work.
the number of solid tumors, let's see if I can. I'm sorry, I don't have enough screens to do everything at once. I believe the number of solid tumors, if someone could check me really quickly, is
it'll be available in just a second.
So sorry, a little slow today.
I'll take over your screen share for one moment so we could show everyone.
That's perfect. Thanks, Ula.
So these are the numbers that we should be getting as soon as Emma's program finishes running.
Yeah, so the idea is, of course, that as you know, Ahmad pointed out in the last meeting, we try to be as transparent as possible, for how the data is pulled, how it's constructed, but also like that people are, I don't know, lose the resistance of trying it themselves and ask other pertinent questions. And, you know, providing the summary overview is not intended to say that you know, you should read 630,000 tumors, but that we want to encourage people to use this. You know, I mean, Ahmed, I know you're an expert and Uta has done this before, but maybe not everyone on the call or in the community. Some people couldn't make it today, but in case, you know, someone ultimately wants to reproduce this or ask specific questions, I think it's very important that we're fully transparent about the approach and what we actually pulled here from the various years.
Yeah, exactly. So as Joe said, this is what the raw data file looks like. Each row is a different patient, as you can see, nice and simple. We are then able to, I hope you can now see an Excel sheet. We are then able to just put that into some simple numbers. So for solid tumors, we're looking at over 6 million, 6.7 million. Heme, we're looking at 850,000. And then here you can see the breakdown per year and per diagnostic confirmation. Just very simple stuff. And then maybe if I can figure out how to work my computer. I'm sorry. This one. Here we go. Sorry about that. We're then, yes, so that's pretty much all that we have. That's the whole data set. It's very simple to grab. The steps, like Arshby said, on the PyCC website, anyone can replicate. The one thing of note to say is that while we would love to just share with you the CSV file of the data, that is prohibited in the data use agreement that you have to fill out with the NIH who runs the SEER data set. But like I said, it's a simple form to fill out to get access to it, to replicate it yourself.
I think that's just very important. So maybe just to add a few sentences. So we of course want others to contribute to this, let's say, data set and look at the data, possibly find something that we will not be able to plot or find. So enabling others the same access and the same strategy of getting to the data is therefore very critical, especially if someone says, hey, we found something else in the data. So I think this is kind of like the call to action in case you're interested, you know, fill out the data use agreement and then walk through the steps that Emma just did. It took me a lot longer than Emma because I tried it as well. It requires a little bit of clicks, so having this recording will probably help to get to the same ground truth data set using the same date range. And then any of the questions you want to ask, of course, is kind of created. If you sign the agreement and get stuck, I don't know if that's fair to say, but you know, we can definitely help. And I know Emma has also put together a screenshot by screenshot part that we will give as an instruction manual in the supplement for the manuscript ultimately, that takes you through the individual steps. Ulla, is that on the website already, or?
Yes.
Awesome. Perfect. Thank you. Back to you, Emma.
And then, yeah, just to wrap it up, we're interested, of course, not only in the past trends, but moving forward and what the trends look like in the future. So if we look here, we can kind of see the 4 big technologies that we're interested in, or that we've pinpointed. Maybe we won't, of course, everything's up to change. Project's still in motion, right? But these are the 4 things right now that we're looking at as big technologies moving forward. And these are just screenshots of PubMed and these keywords over the years. And as you can see, the uptick in each one has been astronomical, and we can only predict even more in the coming years, right? So with this kind of rapid adoption of new technologies, we're really interested in asking the question of what has come before and how can we use the SEER data set to predict what's moving forward using a data set as simple as we just put together today. It's no more than 5 columns.
So one interesting thing here would be to consider making the x-axis the same distance, right, over the years. Because as portrayed now, it looks as if the, let's say, time trend is very similar for each of these, while, you know, some start in the 1800s and others in the 50s. So like getting that like in one axis may be a little bit easier to see, because AI probably is the newest kid around the block. I don't know if that's true when, but
that's a good point. That was an oversight on my part. I'll correct that for sure.
And the other part is that it looks like in the cell-free space there's a lot more individual bars, right? So that seems to be the, I don't know if that reaches the furthest back, but
yes.
So, you know, Uta, because you mentioned the other day that of course there will be a bias in terms of if we pull individual companies' profiles or data. I mean, that may be the best that we can do, but you know, of course the peer-reviewed literature on certain topics is a similarly poor and biased approach, but we discussed that after the meeting earlier in the week, and then we thought of like at least looking at some of these technologies. So this is probably something to discuss also within this team. What are the other buzzwords or other trends, or you know, like components to consider as aspects that may influence the fraction of cancer diagnoses? So this is kind of the request for additional input.
So, hi, my name is Vidya.
Hey.
Hi, I'm sorry, my computer is not working properly, so let me see if I can actually, but I was thinking, I work with Reveal Bio, and one of the things I was, you know, there's a lot of buzzword going around is spatial biology. So that is something, you know, I think liquid biopsy was big maybe like 3-4 years, and now it's become pretty common in terms of early cancer detection. And so I think spatial, you know, biology is also coming up, and a lot of people are interested in single cell as well as spatial biology.
It's a very good point. So spatial transcriptomics, right? And you know,
right,
just spatially resolved like image diagnostics, etc. That would be, no, that's a good point. We should probably run a search for that as well, which I think is probably even earlier than AI. I don't know.
Yeah. That's one thing I was thinking, because AI now can be used, or digital pathology and AI can all be used with spatial biology. So there is, I think, a place where all these technologies can meet, and also single cell analyses, right? Single cell and spatial, and maybe for liquid biopsy, like circulating tumor cells, right? Those also can be used as part of the single cell analysis. Yeah. I had a question. I'm new to this whole digital pathology world. The previous company I worked, right now I work with Reveal Bio, which is an AI-based digital pathology company. The previous company I worked was a sample, company that provided FFPE and liquid biopsy plasma. So is the industry moving more towards early cancer detection and using non-invasive technologies like liquid biopsy? So if that is the case, let's say in a few years or a few decades, where do you think this whole, biopsy, tissue biopsy would be in terms of early cancer detection or even cancer detection?
That's a perfectly valid question that could remain unanswered. I can give it a try. As Niels Bohr said, predictions are very hard to make, especially about the future. I think it will still be there, but it will be supplemented by many things. So what the aim of this SEER project is to basically establish the baseline now, with a firm eye on what else is happening in the near future.
I can see you guys now. I hope you guys can see. Yeah,
Thank you for joining.
Yeah.
So I think we, for example, in the meeting earlier this week, we mentioned that, cell-free is very trendy, right? A lot of people talk about it. It's not the most cutting edge technology anymore, but the FDA has just released a guidance document with a separate work group on it. But at the same time, Uta, who has a lot of experience with international acting oncologists and people from all around the world, knows and made the point that, when you look at a conventional outpatient clinic, it may not be common standard of care yet. Now, how are we going to track this in any systematic fashion? We don't know, but clearly in terms of publications, I think of it, the Nature and Science papers have been published. Now it's finding a niche where it actually anchors in terms of influencing clinical practice. So it is, Uta, sorry, go ahead.
So earlier this week, Ahmad made the suggestion to check the SEER database whether there was data already available for these cases. And I wonder whether you already had the time to do that. Because I just came across a very interesting article about setting up a cancer registry in a clinic, and there the different options, also including circulating or different analytes, let's call it that way, had been implemented already like 10 years ago. And so I do know that it is possible, and you can prospectively establish this data. I just am not aware how this is covered in the SEER, and maybe the author of the article should elaborate on that, Ahmad.
Yeah, Uta, this is something that you have just have brought a very, very interesting point. There are so many articles about liquid biopsy and how liquid biopsy can be utilized as a forefront to understand an early detection of tumor. But what could be a great opportunity for SEER will be to, number one, collate what will be the earliest detection, maybe collating literature, earliest tumor detection or shedding, the earliest shedding of tumor or most shedding tumor in blood, that can be early detected. So far, there are so many literature, but nobody has done a nice compendium of what are the most shedding tumors at what stage, and early detection of those tumors, and what is the mechanism of detection, what is the uh, liquid biopsy mechanism of detection. There are so many, obviously, Guardant, 360, and several others. So understanding the tumor morphology and microenvironment of shedding, all of them are very different. That will give a great summary and starting point of SEERS, and then that will give a great understanding of oncologists on how the liquid biopsy can be utilized by different tumors, um, and morphology of these tumors. But so far has not been that kind of compendium of shedding by stages, how early that shedding can be detected by the tumor morphology itself. But you have just touched on a very, very nice opportunity.
I think some of the aspects of, let's say, the which tumors are shedding and which tumors are not, some of that, I mean, probably not as systematic as you would like, has been done in some of the large population studies. I can send something after the meeting. The issue is that, of course, for this project we included hematologic malignancies because they usually have primarily access to the bloodstream. So most of those studies have focused on solid tumors, and then within the solid tumor field on the epithelial cancers. Although mesenchymal tumors, of course, clearly metastasize hematogenously. The problem with the
Right.
solid tumors is many of those metastasize through the lymphatic systems first.
Yes.
And the early detection in peripheral blood is probably more related to the individual tumor's propensity to seed to lymph nodes. And then the age-old question, do lymph node metastases seed systemically, or is it the primary that seeds systemically? I can send you or a link to a laboratory that is specifically asking that question, and it's a phenomenal set of questions that we're tackling now. Now, to come back, what Vidya just said is, now we have to know what is the heterogeneity in the normal tumor or in the primary tumor and in the metastasis, and look at the peripheral blood. And there are several studies in individual tumors that clearly delineated that, for example, when you compare lung versus breast versus, let's say, something like cholangiocarcinoma,
Mhm.
there are tumors in each subset that are very heterogeneous. And in some of those, there's actually a field effect happening. So then the sample population that you get in the bloodstream may be fundamentally different from, let's say, the earlier, let's say, molecular signatures of some of the clones within the primary. And to bring this back to the SEER question here is, for now, many of these rely on the morphology of, yes, this looks like lung, therefore it's classified as lung cancer.
Right.
And so the question of like where's this going is, of course, the molecular signature may deliver the genotype of the lesion, but for the most part, if possible, people rely on microscopic diagnosis of cancer. But I mean, Ahmed is an expert on one specific tumor that is probably not diagnosed with morphology usually, and some tumors can't be biopsied, right? They are sometimes even diagnosed post-mortem, and then, cell-free is a viable option,
Right.
or I mean, one viable option. Uta, I like the question. I did not have a chance to look whether the SEER database has molecular data or cell-free data yet. I don't know, Emma, if you had, but could you share that publication or the link? No.
It's to be published by the end of June. So I will. Well, the author of the publication is on call as well. So it's Ahmed's contribution to a book, and so he is at liberty to share it. It will be publicly available soon. But I'm just proofing the book right now, so that one. But it's something that he had installed in the past in his registry in Cairo.
May I say something?
Please.
So as I mentioned before, some of the tumors has molecular details in this year, like the breast, prostate, or the most common things, or the things that included that while while the patients being on trials. So yeah, there are some of the tumors that have fields called cancer-specific fields, starting with CS in the SEER database. The point about this, it is not consistent for all the for all cancers. So if what fits for breast cancer does not fit for other cancers. So if they are finding specific marker for the breast in field 1, CS1, then it will be another thing for other tumors like uveal melanoma. So the uveal melanoma CS1 will be about the size, for example. Totally different aspect about it. So while collecting this, the collector should be very cautious, knowing what is the tumor he's collecting, and what are the cancer-specific variables for this tumor. Okay.
Ahmed, just a question. When you talk about molecular markers, are you talking about in situ pathology molecular markers, or are you talking about?
No, it depends. It is a tumor to tumor issue. In a tumor, they call it a cancer-specific marker. In another tumor, it is a cancer-specific variable. It is just a total general variable that describes the tumor. So it is very heterogeneous description for the tumor.
I see.
Okay.
Okay. Very interesting.
Yeah, it is just a specific variable that describes this tumor. Sometimes it is a molecular or a diagnostic.
Okay.
Yeah. So
either amplification, molecular amplification, or in situ, either of the two.
Yeah, it can be anything. It is just a different variable.
Okay. Fantastic. Okay.
The question that I wanted to ask, I don't remember if we have addressed this before. If we have the access to the NACER and the CDC databases that both include the SEER database within them, the SEER data within their data. Why do we use a fraction of them, which is the SEER database? Because the SEER
why don't we use the larger
NACER
database?
Exactly. So why we don't use the NACER or the CDC? I mean the whole the national cancer database of the CDC.
So if I recall correctly, by national stratification, to represent, for example, some of the states, I believe that SEER has the best population-based representation of the entire US population. And there are some biases. I mean, generally speaking, I always want more data. Sorry, I should have said that to start off with. But I think that, if I recall correctly, the representativeness of SEER to the US population is considered in the design, while NACER and CDC is collecting basically on whoever provides data. I don't know, you may know something different, but I believe that was the reason why we initially suggested that. So SEER's close to 50% of the US population, correct?
What I have mentioned is that the SEER covers 30%, while the CDC covers from 99 till 100% of the population. So the SEER cannot by any means better than the CDC. I mean, the National Program for Cancer Registries. And I've shown the curves that describes the variability over the years coming from the SEER data, and also the representativeness of the SEER data, because it showed for example, when I studied the issue, the survival of retinoblastoma, or the survival of retinoblastoma in USA, it showed a decline in the survival, while when I studied it using the CDC database, it didn't show such decline. But this came from that this year comes mainly from less privileged populations in the USA, and it does not represent the whole population. And I have studied this over the last few months extensively because of such discrepancy that I found. I needed to find the clue, or the cause of such variability, and this is what I came with, that this year at the end is not that representative, and even in the incidence, it showed high variability over the years, while the incidence in the CDC showed stability in the incidence. This means that the delays in reporting in the CDC or the NACER databases are less and give less impact on the data sets. I mean, and also the rates, incidence rates. And when we study this also in our study, when we use the SEER database in our study, it will be also affected by such delays in reporting, such malrepresentativeness of the SEER. Okay, so we have to have a strong need to use the SEER, not to use the CDC or the NACER instead.
So does NACER include Canada as well?
The NACER include Canada, but you can separate parts of Canada and Puerto Rico, but you can separate the US alone.
And then, if I'm correct, CDC has temporary changes over the years where different states joined at different times, correct?
and this year also. So starting from 2001, I believe it is not about then the joining. It is about the submission of the data. So in the last year, some of the registers.
I see a point that the databases differ, no doubt about it, and I think the reason where SEER I think had, at least when I looked at it, and I just had to search for the point, the representation of different ancestries is carefully monitored to overrepresent some of the minorities or acclaimed minorities that are otherwise not necessarily represented. So there's a certain not censoring but monitoring of that fraction to enable, for example, a certain representation of minorities. And I think at that time that was prioritized. We can definitely change that and see whether I fully understand your points about incidence or prevalence reports as well as outcomes. But in terms of cancer diagnostics, do both the CDC and the NACER probably does, but they have the same diagnostic modality stringency in terms of reporting? So do they use the same? Yeah.
As far as I know, yes, and the annual reporting, the annual report for cancer does not come from the SEER. The annual report for cancer that is published in the NA journal comes from the NPCR database, the National Project for Cancer Registries, and NACER database does not come from this year because of the representativeness.
So your recommendation would be to use NPCR?
Yeah, actually, yes. So at least the NPCR, if we are not going to use the NACER. The NACER they can provide, I think they can provide us with support, personal support. The NPCR, as far as I experienced till now, they provide access to the data, but they didn't offer support regarding custom databases or so. But the NACER, I was able to get custom data sets from them for my studies.
Mm-hmm. Well, maybe that's a good point to keep in consideration. So let's say the ease of getting to the data in SEER probably supersedes the special requests that we would need to get to the other database. I'm not too familiar with the other databases, so I will definitely take a look into that. Maybe
actually,
yeah. Go ahead.
The United States Program for Cancer Registries is accessible through the website of the CDC, and you can apply now, and you will get the access through the SEERStat software. So it is the same access that you get from the same method is through the SEERStat software. And you will find a new data set within the SEER database. I mean the SEERStat software for the United States Cancer Registry Program. And once you apply also for the NACER, you will find it as another line in the CIRSTAT software. So all of these databases are accessible through the CIRSTAT software. It is the same method.
That's great to know.
Yeah, and also the same statistical methods and so on. I can send you a link, United States Cancer Registries Program.
Yeah, that would be great. Maybe we can take a look, Emma. So like, I mean, especially when it comes, it seems, at least if I understood you correct, Ahmed, the time trends may differ in the various databases, correct? And
yeah, so this year shows an extreme variability from a year to year. This came mainly from the delayed reporting. So some of the registries postpone the reporting or collect the cases of 2 years and submit them together to the CIR database. So you find a year with fewer cases, and the second year you will find more cases that the previous year coming from the same registry, and these fluctuations are not actual fluctuations. These are from the delayed reporting. This effect is minimized when the whole USA is summed together.
Yeah, I mean, we can just check the let's say total sum of microscopic versus not using CIR and then using NACER and or CDC. Question is, of course, how that accounts for when the CIR data is propagating into NACER and CDC. So I presume, I know that CIR occasionally is updated, also backdated, updated, and then it's probably a question whether it was the 2008 data set from 2010 that's in CDC or NACER. But ultimately, if we compare this question across the 3 different data sets and we see the same trend or the same proportion, that would then, of course, massively strengthen the key message. No, that's a very good suggestion. If you could share that link or the login information with Emma, maybe we can take a look what that would look like. Perfect. Other suggestions? I think next week, Friday, is that correct? We're gonna look at some first plots in terms of like figures and or time trends, so we can see whether we can get some of these data sets. All right. There are no more comments.
I have sent the link in the chat.
Very good. And that is for both NACER and CDC?
This is for the CDC.
And NACER is probably over their website.
I found the NACER one. I got it.
Yeah, it is called public data access file, I think, as far as I remember.
Yes.
But you have to register first and then apply.
That's great. Awesome. Thanks for that hint.
Thanks.
All right. Have a great weekend, and I hope to see you next Friday.
Thank you, everyone.
Bye-bye.